This is fundamental problem 18 from chapter 16. In this problem, we want to determine the angular velocity of links BC and CD at the instants shown. So we have link BC here and link CD here. We have distances given to us. We have an angular velocity for AB here. We can use that to find the velocity B. Let's do that right now. So the magnitude of velocity B is equal to the angular velocity of 10 radians per second times the distance from point A to point B. That's 0.2. So that gives us 2 meters per second for the velocity of point B. Next, we want to find the instantaneous center of zero velocity for link BC. So I have velocity B and I have velocity C. If I draw a line which starts at point B and is perpendicular to the velocity vector, that goes like this, and then drawing a line which is perpendicular to VC, passing through point C, that gives me this. And I have located the instantaneous center of zero velocity. This is for link BC. So I have two different angular velocities here. So I have a different instantaneous center of zero velocity for link CD, but that would just be at point D. So using the formula which they give us in the green box here, which is for the magnitude, we can say if I'm looking for the angular velocity of BC and I know the velocity of B, I take the angular velocity and multiply it by RB over IC. And I'm looking for the angular velocity. So I take VB and I divide it by RBIC. Because this angle here is 30 degrees, this angle here is 30 degrees, this is RB over IC, this is 0.4 meters, so RB over IC is 0.4 divided by, since this is the adjacent side, the hypotenuse is the adjacent side divided by cosine of 30 degrees. So we can put this in here, we can put that in there, and for our angular velocity we get 4.33 radians per second. This was for link BC. Also for link BC, we can say velocity C is equal to angular velocity BC times position of C measured from the instantaneous center. And we can find that this is the position of C measured from the instantaneous center, this distance here. And I know my angular velocity, this is BC. So I have 4.33 radians per second times this distance here, which is the opposite side, if you're looking at this angle here. So that would be the hypotenuse. My hypotenuse is 0.4 over cosine of 30 degrees times sine of 30 degrees. And that gives me 1.00023 meters per second for the velocity of point C. Then finally, I can find the angular velocity. So for link DC, this is the instantaneous center. This distance here is 0.2. So I can say the angular velocity for CD is equal to the velocity of C divided by 0.2, because that's this distance here. So that's 1.00023 meters per second divided by 0.2 meters, and that gives me 5 radians per second. So in this problem, we had two different angular velocities we were looking at. So we used this formula for point B and for point C for link BC, and then we used a similar formula rearranged for link CD to find the angular velocity of CD. So that concludes fundamental problem 18.